travel time index tells you how good traffic is right now. It divides the current speed by the free flow speed. And so the best value we can have is 1. When people move at free flow speed, and now the more congestion there is, the higher the number would be for the travel time index. Another measure for level of congestion would be the planning time index, and this site, if you push on a particular part of the road, it gives you a graph for the planning time. So the software keeps track of the differences of travel time over time period, and it captures the worst situation. So the day on which we had the slowest speed, and so it takes, in other words, slowest speed or highest travel time, it gets 90%, 95% of the worst case travel time. And then it gives you planning index. So it helps people figure out, okay, if I have to be there, if it's a very important trip you want to make and you don't have to be late, then you use this as a worst case scenario, how much it takes you in the worst congestion. So this is how website should look when it's performing well. And so here it allows, if you pick a particular street, and then you can go and you look at the analysis. And so here I'm showing a pretty good situation where we have close to free flow speed. So average speed is in red and free flow speed is in green. So it's barely noticeable worsening of the traffic. And the last type of work in transportation I want to mention is isochronal mapping. So isochronal map is a map where every contour shows similar travel time. And so the foundation of those types of maps, and there are a couple of attempts to make a website, but they are not so good yet. So I'm following to see when we get a good real-time isochronal mapping site. So the behind the scenes, there is a network. So the network is structured as links and nodes, and there is some variation of Dijkstra's algorithm. I'm not sure how to pronounce Dijkstra's algorithm, some variation of it. And we run the software calculates the travel time from where you are located to other places, and then an interpolation, it's a GIS interpolation is done on that interpolates among the centroids of the zones, and then there's cartographic polishing, and the result is a map like that. So here we start from, this is a rush hour in the valley, 2012 AM peak. So we start with Fountain Hills, and how far can you go if you drive? So it's in minutes. So for 10 minutes, up to 10 minutes, you can get up to here. For 20 minutes, you get here. For 30 minutes, you get here, and so on and so forth. So it gets you, and it gives you an idea of how far can you go. So there's a lot of demand from the business community, because when they are looking for a place to relocate, so they want to know, okay, if we're here, how far, they try to determine how far away to stay from a warehouse or from an airport, or which place to pick. And so there's a huge demand for on-the-fly calculations like that, not a static one. And it's pretty extensive algorithm, because it's behind the scenes right now. It has a graph with 2,000 nodes, 2,000 zones, and much more nodes. So I expect that it will be very soon somebody will come up with a website that's gonna be able to do those types of calculations on the fly, and it will be very useful. And so one step back, so how the algorithm works, so we, as a first step, we have travel time between the zone of interest to each and every other zone. And so the red dots, centroids, a zone that are accessible within short amount of time. Yellow is like half an hour time, and then the green or bluish, it's like it's probably an hour time. But this is a 100% just procedure to interpolate after the initial run. So where is the field going? There will be more use of cloud computing. However, and there is a company, Cube, that have been successful to put child demand models on a cloud. However, so far their clients are small agencies. Now, in transportation modeling, there is a lot of local knowledge and a lot of high level of customization. So it's hard to get the model from one city and just use it in another city because demographics are different and employers are different type of employers located in different places. So in other words, child demand modeling is not a portable thing to do, and that's the basic hurdle for exclusively using cloud computing for that. The degree of customization that's required to adjust to the specificities of the area makes it hard so far to use it in cloud computing. So also, people used to spend years to compile data sets. Now the time for creating and updating data sets is very fast, and there's almost on the fly data compilation. Now, it's a controversial topic. Is it good or bad that we can be tracked? So I'm going to give you a, I guess, good example of when it helps to be tracked. This is location-based services. So you probably know what location-based service. I'm going to give an example. You understand what I mean. So a pizza chain. So they have a GIS data set with their locations. They have a network, and they get people to subscribe for notifications about promotions. So what they're going to do is, like, as people drive and they give them permission to be tracked, so there's an algorithm that's going to check, is there a user within the service area? Let's say service area is 10 minutes of the pizza place. So as you drive along, so your Bluetooth, so your cell phone is going to send signals. So once you are within 10 minutes from the pizza place, then there'll be a notification. Hey, we have a 2-for-1 sale within the next 2 hours, so pay $5 pizza or something like that. And so if you care, you can, because you're within 10 minutes of the place and you go there, once you walk in, they ask you, well, how did you hear about our promotion? If you tell them, well, I have this app that sent me a bus, then they know. If there are enough of people to get to the pizza place that way, through a location-based service, then they probably are gonna, so the company is gonna charge them, it's gonna be free for the users. So that's a basic example. A more serious use is like some owners of luxurious cars, they have this feature where a roll-off accident in the middle of nowhere, then 911 crew get notified and go and pretty much save the person's life. It's the same principle. So it's always, as a vehicle moves, it constantly sends signal that's captured by the satellite, and it's searching for how far you are from the service area of 911 or business, whatever, how far you are in minutes. And so they determine that if you showed interest, then they get to you. So it's been a while for quite some time, but it's getting faster and more widespread. So next time that they ask you if you're interested in a sale, just be aware what it means. I mean, the most advanced types, they will alert you if you are within whatever, some small amount of time from their business. So I am here with this slide. I'm trying to make a point how a more effective communication map, how it's better to communicate information with a map. It's quicker and more effective than tables. Now here this is information, this shows traffic. This is truck traffic between different zones in our area. And you can see, I don't have the freeways, but this is I-10 here going Tucson, I-10 going west, and I-17. So if you want to know where freight traffic is, and you look, you get a distant idea. The same information would be like, I don't know, a bunch of tables, which you tell people, okay, in this zip code we have so many trucks, in that zip code, and it still conveys information, but here people, especially non-professionals, much quicker understand what you're trying to convey than if you use tables. And so I'm going to end with my personal creed. I think that if a picture is worth 1,000 words, a map is worth 1,000 tables.
Any questions?
I had a question. I'm Mindy. I'm a PhD student here. I'm curious about how you talked a lot about real-time applications and how things are progressing.
Yeah.
So they're quicker and they're more like right now.
Yeah.
But how can GIS help in tracking historic changes or things that happen over time as infrastructure changes, and you might want to look backwards to see how a city developed or how it grew or how growth may change over time? Is there any means to track that through the database, or is it more just like it's what we have now and we're only looking forward?
Oh no, there is a way to do that, and it's done both in urban planning in many areas. So what you do is, you cannot have too many moving parts. So if you want to track changes over time, you get a fixed study area. So you focus on, I don't know, you get a study area and you collect the data for different time periods. So you apply same data structure, and you have, say, if it's changing roadways, you have for 20 years in a row, you can have 20 different data sets. Or if an aerial photography is, but let me give an example. So if you have for the same study area, you construct the data set for different time periods, and there is a way to add time component as an attribute to the data set, and so there are slick ways to run an animation. And so if you have data for 20 years in a row, then you have same data structure over same spatial extent, and you have time stamping for every data set. And then there's software that would do pretty much an animation, so it can slowly or quickly show the change over time. And it's done multiple times, so I mean, if you consider doing something like that, I can help you set it up. So it's not difficult conceptually. 80% of the work is just to data entry, data cleanup, data organization. So it's mundane and it's not really fun to do. But the final product, like an animation, is very cool. And I think, yeah, we have done things about the valley, like how I've seen this animation, how the valley grows. So what is it in 1991, 92? And so as you have more and more developed areas, so it's very slick animation. It just shows how it's like a wave moves, you know, population moves and sprawls. So urban sprawl is perfect candidate for time series animation.
What kind of coursework do you need to get a job like yours?
Most of the people who do, it depends whether, so there are many ways, a few ways to do this. So you can get a degree in transportation engineering and then kind of do an additional certificate of specialization in GIS. I started with, because I started with automation, so my background is, my first degree was in electronic engineering, but then I got into processing transportation related data. So I started with parcels data sets, and I was doing utilities. So because I was dealing with civil engineers, I took classes in civil engineering to be able to understand them, because I don't want to say anything silly when I deal with them. So I took half the credits necessary for civil engineering after I got my electronic engineering degree. And then I got a master's in GIS degree. But it depends what you want to do. Like, if there is a lot of money to be made into all these algorithms that are used to optimize routes and to pretty much these location-based services and all that optimization of in logistic and optimization of routing, but requires heavy-duty mathematics and programming, because still there's a lot of demands for like website that do interactively calculate you time, interactively the maps I showed about Fountain Hills. And so if you like mathematics and programming, and doesn't matter, you can start with programming and then go in GIS, or with engineering go GIS, depends what you're interested to.
That's it. Are there any more questions? Okay, I hope this presentation is useful for all of you to get some insights about the GIS application in transportation research field, as well as how GIS is actually useful in our daily travel activities. Once again, I would like to thank Petya for coming all the way from MAC to give a presentation during business